Abrasion resistance of concrete. It refers to the ability of concrete to withstand the wearing and erosion caused by friction, rubbing, and scraping forces. Moving to the next slide. Importance of abrasion resistance. First one is the durability and longevity. Uh, in high traffic area, industrial floors, pavements, and transportation infrastructures of concrete is often exposed to constant friction and abrasion. Improving resistance to wear helps extend service life of these structures, reducing maintenance and replacement costs. Next one is the cost saving. Structure with high abrasion resistance requires less frequent maintenance and repairs. Safety consideration in transportation infrastructure like road surface with good abrasion resistance provide better skid resistance, reducing risk of accidents. In industrial setting, a durable abrasion resistance floor contributes a safer working environment, minimizing the chances of slip and falls. Uh, Next one is the environmental consideration. Reduce wear and abrasion mean that the fewer particles are generated from concrete surface, resulting in less dust and particulate matter. This can have environmental benefits, especially in urban areas where air quality is a concern. So, what is blast resistance? Blast resistance is the capacity of concrete structures to withstand the intense and sudden forces generated by explosive events like terrorist attack, industrial accident, and military operation, where structures needed to endure the impact of shockwaves and debris. The design and construction of blast resistance of concrete involve considerations such as material strength, ductility, energy absorption capabilities. Uh, the goal of blast resistance is to create structures that can effectively absorb and dissipate during the blast and protecting occupants and preserving the structures of building. So now I like to invite my friend Rex to explain more briefly about abrasion resistance.
Hello. Good evening, everyone. I would like to thank my friend David for the insightful overview of introduction of abrasion blast resistance. Now, building on his topic, let's dive deeper into the topic abrasion. The durability of concrete has received uh, increasing attention so far, and so far the previous studies focus on investigating the mechanism, failure behavior, and enhancement algorithms against aggressive medium, and it aims to improve the durability of concrete structures. But unfortunately, the studies considering the mechanism of abrasion as well as the design of high abrasion concrete are relatively insufficient. So in this experiment, we will develop a high anti-abrasion, ultra high performance concrete with enhanced volume of key factors on the performance of UHPC stability through investigating the effect. Moving on to the next slide. Moving on to the, moving on to the next slide. I would like to discuss about the factors affecting the abrasion resistance. First and foremost, the aggregate types and sizes. For example, it is shown to through the research and experiments that the coarse aggregates and hard aggregates are more resistant towards the abrasion materials. One of the major factors which plays a crucial role in abrasion resistance of concrete is the cement content and its types. So it is shown through research and experiments that concrete having a high cement content has more abrasion resistance. One of the other factors is water cement ratio. So high water cement ratio causes high porosity, and that increases the voids in a concrete, which is more prone to abrasion. So it is recommended that the water cement ratio would be low so that it is added more resistance against abrasion. One of the major factors of abrasion resistance is the surface finishing. It plays a crucial role. because if the surface is smooth, then it will have a very less friction again wear and tear of the abrasion materials, and it would be highly resistant against the abrasion. Other factors include supplementary materials and thickness of concrete. Uh, there is a lot of influence of aggregates and cement type on the concrete, such as the rubberized concrete. It showed better abrasion resistance than the control mix. And water cement ratio did not significantly influence the abrasion resistance, with higher ratios resulting in increased resistance. Weak bonding between cement paste and crumb rubber did not affect abrasion resistance, despite impacting compressive strength. Pozzolanic admixture is the material that is added that when added onto a concrete, it reacts with the calcium hydroxide and forms the cementitious materials, which benefits the concrete by increasing its density and strength, reduces its permeability, enhancing binding, improves surface hardness, and mitigation of alkali silica reaction, and it leads to have a high abrasion resistance of the concrete. Now, I would like to discuss for the recommendation for improving the abrasion resistance. First of all, the aggregate selection. As we have to mind the aggregate selection by selecting the coarse aggregates and harder aggregates so that it has more resistance towards abrasion for the concrete. We have to use the pozzolanic admixtures, for example, such as fly ash, silica fumes, so that it has more resistance against abrasion. We have to adjust the water cement ratio and enhance the surface finishing, making it more smooth so that it has less wear and tear against the abrasion materials. So in this research materials, we are mainly focusing on the three experiments. First is the ASTM C944. This test involves the rotating a cutter assembly against the surface of a concrete specimen under a constant load. The mass load of the specimen is measured and used to calculate the abrasion resistance. Another experiments is such as ASTM C1138. This test involves the use of a specified abrasive material such as carborundum grit under controlled conditions to abrade the surface of the concrete specimen. Last but not least, the ASTM D968 experiment. This test involves dropping abrasive particles onto the coated surface under controlled conditions. The extent of the coating wear of damage caused by the falling abrasive is then evaluated to determine the abrasion resistance. Now, the results from the abrasion resistance test includes the mass flows, and it is a common parameter used to quantify the abrasion resistance. It represents the weight of the material removed from the surface if the specimen during the test. Another such results includes the volume loss, and it accounts for the physical loss of the material from the surface, and is often calculated based on the geometry of the specimen and the measured depth of the wear. Last but not least, the abrasion resistance index. This index allows for easy comparison of abrasion resistance among different materials and mixed design.
Now I am going to discuss the topic blast resistance. At first I will explain that what is blast resistance and what are its importance in various applications. So what is blast resistance? Blast resistance is the capacity of a structure or material to withstand the effect of an explosion or blast event without significant damage or failure. This includes the ability to endure the high pressures, shock waves, fragmentations and other destructive processes generated by an explosion. Moving on to the next slide. Uh, so these are the various applications in which blast resistance is important. First of all is military bunkers. Military bunkers are designed to provide protection supplies during combat or in event of enemy attack. So blast resistance of concrete is essential for military bunkers to withstand the force of explosion from artillery and bombs. Then there is nuclear power plant. In nuclear power plant, concrete is used to construct critical structures such as contaminate buildings and reactor facilities. Blast resistance is vital to ensure that the structure can withstand potential hazard, including both internal and external explosion. Then there is Transportation infrastructure. Blast resistance concrete is essential for transportation infrastructure such as building bridges and tunnels. Now, moving on to the next slide. Now, in this slide, I am going to discuss the test on blast resistance in concrete. There are various tests performed in order to improve blast resistance in concrete. First of all, there is a shock tube test. In this test, materials or structures are placed inside the shock tube, and uh, the effect of blast resistance pressure and impulse loading can be measured and analyzed. Then explosive test. This in this test, an explosive material of varying size and types are placed at different distance from target structure or material to find the impact of explosion. Then there is a ballistic pendulum test. This involves firing projectiles at higher velocity into the material or structure to stimulate blast effect. There are other tests like blast chamber test, scaled model test, and fragmentation test in order to improve blast resistance in concrete. Moving on to the next slide. These are the experimental setup for the various experiments. Uh, then uh, uh, here are some potential findings that may result from blast resistance test. First of all is structural integrity, then deformation and displacement of structural element or material, then damage assessment. In this, the severity and extent of damage can provide insight into the structural performance under blast loading. Then energy absorption. This this can indicate the capacity of structure to dissipate energy and resist progressive collapse. Moving on to the next slide. Here are some important recommendations for improving blast resistance. First of all is reinforcement concrete construction. Reinforcement concrete structure are more resilient to blast effect compared to other construction material. Blast resistance design principle. This include considering blast loading scenarios, understanding structural vulnerabilities, and implementing mitigation measures accordingly. Then there is explosion resistant glazing. There are many other recommendations like using high strength concrete with compressive strength exceeding 40 megapascal and using high density aggregate. Uh, Installing explosive venting system to redirect blast pressure away from the structure, applying blast resistance coating, increasing thickness of concrete wall and slabs, and increasing stand-up distance between structure and blast source, and implementing security measures. Then, in conclusion, ensuring blast resistance and abrasion resistance in concrete structure is essential for their durability and safety. Incorporating high strength material reinforcement and specialized coating mitigates damage from explosive events and gradual wear. By prioritizing these measures, structures remain resilient against both sudden and long-term environmental challenges, ultimately extending their lifespan and minimizing maintenance costs. With this, I will like to conclude our presentation. Thank you. Uh, so these are the references for our presentation.